What we need to consider is the fact that, let's say I know the absolute value of 7 is 7. Well, I also know the absolute value of negative 7 is 7. So what that means is basically we're going to need to set up two equations for all these absolute value equations. Now, in order to do that, though, our first step is going to be to get the absolute value by itself. So we need to do that before we get to that point. But it's still going to be an important step to do two equations. So let's look at this first one. Absolute value of x minus 3 equals 7. Well, that means that x minus 3 equals 7 is going to be one of our equations. So x equals 10 is one of our answers. What's also true, though, is that negative 7 can equal 7. Now, there's two different ways that you could write this out. Which way you choose is completely up to you. What I do is I usually take whatever is in the absolute value, and I do the negative version of that. So a negative x minus 3 equals 7. And what I typically do is I don't usually write it this way. I typically just go ahead and negate everything that's in it. All right? Now, that's not the only way you can do it, okay? But let me go ahead and solve it. I get x equals negative 4. All right, let's say I left it like this. Then I could divide by negative 1. I still get the same answer. The other option, depending on how you're taught, you might see it this way in the book. I could just set it up as x minus 3 equals negative 7. So I end up with x equals negative 4. Again, I'm still getting the same answer. The big thing is just don't do both things, okay? Don't do negative x plus 3 equals negative 7, because you're going to get the same answer as the first. But what I will typically do is take whatever is in the absolute value and change the signs. For me, that just makes it a little bit easier when we get to inequalities. That's the only reason I do it that way. But if you're going to do it right the other way, totally fine. All right, so let's move on to the next one. The absolute value of 3x plus 1 equals negative 5. Well, the absolute value is by itself. And again, let's think about what absolute value means. It's that distance of that number away from 0. Well, I can't have a negative distance. Absolute value cannot be a negative number. Absolute value is always greater than or equal to 0. So that means this graph has no solution. We don't even need to solve it. If we did solve it, we would get answers. But what we would get is something called an extraneous solution. An extraneous solution is basically something where you do all of the algebra right, but because of just the features of that graph and the characteristics of it, your answer isn't actually an answer to that equation. What that means, you're going to see this come up in a lot of the equations we do this year. What that means for you guys is check your answers, plug them back in, make sure they work. It's a really important step. All right, again, let's think about this graphically now that we know what the graph looks like. All right, the absolute value of 3x plus 1 as a graph would be shifted left with a little bit of a stretch on it. The line y equals negative 5 is down here. Every equation is really asking, hey, what's the intersection of this and this? Well, in that case, there is no intersection. There is no solution. All right, let's try another one. Before we make that decision about negatives, you have to get the absolute value by itself. So the first thing I have to do is add 9. And now, once that absolute value is isolated, now I can go ahead and set up two equations. So I get x equals 4 as one possible answer. And x equals 0 as a possible answer. I haven't boxed them yet because I want to plug them back in and make sure that they work. So in this case, both of these solutions do work. All right, let's look at D. The absolute value is already by itself. Let's set up our two equations. All right, so there is one possible answer. And there's another possible answer. All right, plug in 6. That one does work. If I plug in negative 2, without even solving the whole thing, I can tell that negative 2 is not going to work. Because if I plug in negative 2 over here, I'm going to get the absolute value of something is equal to negative 8. Absolute value cannot equal a negative number. So since one side of that equation is giving me a negative, That is an extraneous solution. It's not going to work. Again, thinking about this graphically, absolute value of 2x plus 12, that's going to be stretched a bit, shifted a bit. Looks something like this. Y equals 4x is going to look something like this. That's only going to intersect in one point. All right, so again, you only have one solution. The other one is just extraneous. All right, now at this point, if you feel pretty comfortable, I would pause the video and try a couple of these on your own. All right, so let's go ahead and look at this next one. So we'll do the positive version. I get x equals 7, plug it in, that works. I also want to do the negative version. Now, I don't need to make both of these absolute values negative because that's going to be the same thing as the original. So just make one of them negative. Doesn't matter which one, you're still going to get the same answer. And I get my equation or my answer. Very similar here on F. Okay, start with the positive version. But this time, if I subtract x and I subtract 5, I get a very false statement. Okay, that is not true. So the positive version of this is not going to give us any answers. Well, let's go ahead and look. Let's make one of them negative, and let's see if that gives us any answers. So x equals -8. Plug that in, that does work. So we do have one solution here. Again, think about the graphs, okay? X plus 5, shifted left 5, x plus 11, shifted left 11. They have the same slope, there's only going to be one intersection point. All right, again, on this next one, at this point, it's really the same strategies you guys have seen, just a little bit of different solving. So again, the absolute value was as isolated as it could have gotten. So one possible answer is 14/3. I will tell you that one does work. We'll do the negative. And I get -10/13 as my other answer, which also works as well. Now, as I said for graphing, when it comes to solving, you need to understand how to solve these equations without a calculator. Even if you have a calculator sitting in front of you, you need to know how to solve these without a calculator, because it's going to be a skill that's just going to be assumed that you know in your future math classes. So don't cheat yourselves by doing the work without it. But if you want to use a calculator to plug these back in just for time's sake, to see if your answers are right, that's fine. Okay, but again, we need to understand how to do this process without a calculator. All right, on H, very similar, but we're going to tie back in some things you guys did in Algebra 1. So let's start with our positive one. And we have a quadratic equation. Hopefully you guys remember, in order to solve a quadratic, you have to set this equal to 0. The easiest way to solve a quadratic, if you can do it, is factor. We're going to factor a ton this year. So if you don't remember how to factor, you may want to look back at some of your Algebra 1 stuff. We are going to do it a ton when we get to the quadratics unit, but you'll see it here and there until we get to that point. All right, so since A is 1, this is an easy question. Okay, what multiplies to -6 and adds to 1? And those are my numbers for my factors. So my two possible answers are -3 and 2. And both of those do work out. But remember, that was only the positive of my absolute value. Now I need to do the negative. Now, I don't like to factor when A is negative, so I'm going to move everything over to the right. And this is actually something you can factor, okay? It's a really easy thing to factor, but sometimes that gets forgotten. I don't want to see you guys use the quadratic formula on this, okay? I also don't want to see you guys divide by x on this, because you're going to lose some of your solutions if you do that. What we need to do is factor out our GCF. Our GCF is x. So then my two factors give me two possible answers of 0 and 1. So again, probably one of the easiest ones to factor, but one of the ones that's kind of the most often overlooked. All right, this next one, again, this is just another property of absolute value. If you have that fraction, you can separate that into two absolute values, which means I could then multiply by that bottom absolute value. And now I have an equation just like I've already worked. Okay, so again, at this point, it's a pretty simple equation. So I end up with x plus 1 equals 15 minus 5x. 6x equals 14. And I'm just about out of space. I get x equals 7/3, which is a correct answer. The negative one, x equals 16 and x equals 4. And both of those answers do work, neither one's extraneous. All right, so our last two are probably the most intense algebraically. So looking at this first one, what you'll notice, you have an absolute value inside an absolute value. Let's start with the most outside absolute value. That absolute value is already isolated, which means at this point I need to set up two equations. One equation is taking whatever's in that absolute value and making it positive. Equation number 2 is taking whatever is inside that absolute value and making it negative, which would be the negative absolute value of 2x plus 5 plus 3 equals 10. So those are the two equations that split from that yellow absolute value. I have not dealt with this absolute value yet, and that's okay. So at this point, let's go ahead and try and solve this purple one. We have a new equation now. So my goal now is to get this absolute value by itself. So the first thing I would do is add 3. Now it's a very easy equation that we did just at the very beginning. Split it into 2. 2x plus 5 equals 13. And do your negative equation, negative 2x minus 5 equals 13. And you get two possible answers here. Plug them back in, make sure they're not extraneous. Neither one is, so x equals 4 and x equals negative 9 are both possible answers. All right, now let's solve this equation up here at the top. Okay, let's get the absolute value by itself. And when I do that, I get the absolute value of 2x plus 5 equals negative 7. Now, you can work this out and test for extraneous solutions, and you're going to get extraneous solutions. If you can recognize at this point what's going on, it's going to make your lives a little bit easier, because the absolute value of 2x plus 5 cannot equal a negative number. So at this point, there are no more solutions. So you only have two solutions to this equation. All right, the last one here is a little bit messy, because what's different here, we can try and isolate those absolute values, but they're really never going to be isolated, because this 6 is kind of always going to be in the way. So what we need to consider here are the different cases that could happen. So just like we've done, we've looked at the absolute values both being positive or negative. On these previous ones, though, like where you had the absolute value equal to an absolute value, we didn't have to worry if these were both negative, because that's going to be the same as if they're both positive. Well, when you add in an extra number, that's not the case. So what we have to do now is really consider all 4 cases of these absolute values being combinations of positive and negative. So the first case we'll look at is if both absolute values are positive. So that would be 3x minus 2 plus x plus 2 equals 6. So that gives me my first possible answer. X equals 3 over 2. Plug it back in. This one is not extraneous. All right, let's try our second case. Both of those absolute values are negative. All right, again, because of that additional number, this is not going to be the same thing as if both of them were positive. So I'll do negative 3x plus 2, not plus, minus x minus 2 equals 6. So taking what's in both of those absolute values and making both of them negative. So that gives me negative 4x is equal to 6, and x equals negative 3 over 2. Well, if you plug that back in, you're going to notice that's extraneous. All right, let's look at our next one. So one other possibility is if the first one's positive and the second one's negative. So that would be 3x minus 2, and then change the signs of the second one. So then I get 2x equals 10, and x equals 5. Plug that in, not going to work, it's extraneous. And then finally, the last case is if the first one is negative and the second one's positive. So negative 3x plus 2 plus x plus 2. So negative 2x is equal to 2, and x is equal to negative 1. That one does work. So that leaves me with 2 solutions that do work and 2 solutions that are extraneous. There are 2 points of intersection of this graph. All right, so the last thing we're going to do is we're going to look at some application questions. Now, I will tell you on this first one, it's pretty obvious what the answer is. You probably don't need an absolute value equation to actually solve this. You can pretty much figure out, hey, it's 106 and 86. But it's important to understand how to write this as an absolute value equation, just because that's something that can come up on ACT, SAT. So the average temperature is 96 degrees. It can vary by 10 degrees more or less than that. So the way we would write that absolute value equation is basically if I take the temperature and I subtract 96, then that is going to be 10. Because again, if I end up with, we'll go ahead and solve it actually so you guys can see. That means T minus 96 equals 10, so I can get a temperature of 106. I also could do negative T plus 96, and I get a temperature of 86. So you get the 2 answers that you would expect. But it's important to kind of understand how these absolute value equations work. Really what you have here is your midpoint and kind of your differential. And that's kind of the basic setup when it comes to those absolute value equations. All right, so this last one is really kind of more of a graphing kind of equation. It kind of combines graphing with this equation solving. So Jim passes Dwight a basketball. Jim is holding the ball at a height of 4 feet when he passes it. So let's say here's 0, 0. Let's say this is Jim and holding the ball. That means the ball is going to be at 0, 4. All right, he bounces it 3 feet away from him. Well, it's going to bounce on the ground, and that ground is 3 feet away from him. So at 3, 0, that's the bounce. Dwight is standing 2 feet from where the ball bounced. So Dwight is over here at 5 something. All right, it wants to know how high he catches the ball. So what we know is the ball is going to bounce somewhere over here. We know it has an x coordinate of 5. We don't know the y coordinate. So the easiest way to find this, since we have this picture, let's just write the equation of this graph. Well, there's an absolute value function. There's a vertex of 3, 0. All right, all I need now is that slope. That's a slope of 4/3. There's my equation. To solve this equation, I know that x is 5. So f of x is equal to 4/3 times 5 minus 3. So 8 over 3, which you don't really say 8/3 of a foot. We'll say that's 2 2/3 of a foot. If you want to go ahead and convert that to inches, go ahead. But we'll just leave it at 2 2/3 of a foot. All right, so that is it for absolute value graphs and equations. Next class, we are going to look at absolute value inequalities.